Welcome to the Module 5 contents of robot programming languages. So under robot programming language and system, we are supposed to go through the levels of robot programming, sample application, requirement of a programming language, proper peculiar to robot programming language. So here robot programming language and system, here different type of controllers have been used by different companies, and it has to be adapted at the workplace so that required output it is achieved. So here different type of conveyor systems, parts feeder, fixtures. At the work cell it is interconnected in the factory wide network so that a central control computer can control the overall factory flow. The programming of manipulators is often considered within the broader problem of programming a variety of interconnected machines in an automated factory of the work cell. So there are three levels of programming language. One is teach by show. So there will be a teach pendant where by showing the different location, the start and the end point, if we keep on recording, and at last if we play back, it is going to show the required output. So robot programming language, it is especially manipulation language. Robot library for an existing computer language, robot library for new general purpose language. So like this, different types of programming languages are available. So task level programming language, it tells about what task it has to be performed. For that, so specific commands are used to perform the task by the robot. So border between the explicit robot programming language and task level programming language is quite distinct. Incremental advances are being made to explicit programming languages to help raise the programming, but these enhancements cannot be counted as component of a task level programming system. So sample applications of the programming are conveyor signal to start. Vision system judges the bracket position and orientation on the conveyor and inspects the buckets for defects such as wrong number of holes. Using output of the vision system, bracket is placed on the in the fixture. The bracket is placed in the fixture of the work surface. So conveyor can be signaled to start again for the next bracket. Step 1 and second begin in a parallel with the following steps. So further a pin is picked from the feeder and inserted part way into the tapered hole. Like this, the sequence it keeps on going for each component, and it will be added in the required palette all the components by the robot. So by the vision system, you'll be able to use the maximum. So here when we define the motion specification in the Val2 programming language, move goal 1 moves goal 2, move via 1, move goal 3. So in AL programming, the manipulator gram, it is used move gram to goal 1, move gram to goal 2 linearly, move gram to goal 3 via 1. Like this, the motion specification is done. Flow of execution and programming environment. So here the flow of execution, it is checked at the workplace. So work cell and work simultaneously to reduce the cycle time of the process. Signal and wait primitives are often found in robot programming languages. So here the ability to specify such event monitors easily is afforded by some programming languages. So programming environment must be with the trial and error method. So now all the programs are interpreted based on the need. Sensor integration, move gram to the goal with stiffness. Like this, different wordings are used. For that, we are going to integrate the different type of sensors. Problems peculiar to the robot programming. Internal model versus external reality. Error recovery. So if you want to come out with the errors, how to come out of the thing. So first problem is to identify that error has occurred, because the motion will be happening continuously at the faster rate. Error detection, it is quite difficult. So this test may involve checking the manipulator position to see that it lies in the proper range. When doing an insertion, lack of change in position might indicate jamming or too much motion. Every motion statement in the program might fail, so this explicit check can be quite cumbersome and take up more space than the rest of the program. Attempting to deal with all the possible errors is extremely difficult. Usually the few statements that seems most likely to fail are checked